is Unmasking the Subnet Lookalike IP Ranges in Cloud Environment by Asaf, Aprozper. Quick shout out to our sponsor, JupyterOne. JupyterOne specializes in cyber asset visibility and management, connecting the dots between assets, people, and risk across your tech stack. With one centralized view of assets, security teams can answer complex questions, make data-driven decisions, and stay secure. We'll be taking questions after this talk. Yeah, take it away.
Thank you so much. Cool. So, hi everyone. Can you hear me? Yes. Cool. Welcome to my talk, Unmasking the Subnet, Lookalike IP Ranges in Cloud Environments. My name is Asaf Aprozper, and I'm really excited to finally be here at Forward CloudSec. For the past few years, I've been living and breathing cloud security. I lead the SecOps team at Moonactive, a gaming company where we've got a massive cloud infrastructure to keep secure. We use AWS and GCP, and let me tell you, it's a big deal with our global network of DevOps teams. It's been more than 3 years since my last talk. In the past, I've talked about things like memory process injection, threat hunting, and external attack surface at places like CodeBlue Japan, B-Side Cyprus, and Black Hat USA Arsenal Talk. But today, it's all about cloud security. I would like to start with some interesting fact. Did you know that misconfiguration was the #1 reason of cloud security incidents in 2022? Yeah, that's right. Misconfigurations were reported by 23% of the organization as their biggest security issue. That's followed by data that got accidentally exposed by users, 50%, and account compromise, another 50%. So we've got a lot to unpack today. Let's take a look at what we'll be diving into. First, we'll take a look at misconfigurations, which are often a major source of security issues. We'll discuss common misconfigurations, the process of proactive threat hunting, and we'll introduce a new kind of misconfiguration that's affecting all cloud environments. Next, we'll be taking a trip back in time with RFC standard, which defines private IP addresses, and we'll look at how it applies in today's cloud infrastructure. We will also talk about how to assess the scope of security issue. This involves identifying the specific problem and using different resources to understand its impact. After that, we will go into how to set up and use a proxy. This is an important skill to scanning our misconfiguration and keep hidden. And we'll use some open source tools. Finally, we'll share some Splunk and Sigma rules for hunting that new risk, and we'll introduce 2 new tools called IP Unmasker for the red teamer and Security Group Unmasker to the blue teamer. Let's get started. So we're all familiar with the moment when someone ends up making a security group that's open to anyone on the internet for inbound access. I'm talking about when cloud users used Quad 0 in the security group instead of the organization VPN address range or specific IP addresses, such as the office IP. When you expose your cloud infrastructure to everyone on the internet, it's like leaving your front door wide open. You're practically inviting security risks. Give it about 5 minutes and you'll start seeing external attacks coming in like swarm of bees. Things like port scans, log4shell payloads, and other sneaky exploitation attempts, even when they have no clue what platform you're running behind your exposed asset. But hey, it's easy to get mistake, right? Especially when AWS sends out the public exposure CIDR block, Quad 0, as the first choice when you're setting up an inbound rule in your security group. Yeah, that's one. But in this talk, we're going to dive into a new kind of cloud misconfiguration that is affecting all cloud vendors. I name it as Lookalike private IP ranges. So you might be curious how this new cloud misconfiguration discovered, right? Let me tell you, it wasn't easy. But that's what make it fun. Let's dive into the journey, starting by clarifying what proactive threat hunting means in the world of cybersecurity. Well, proactive threat hunting is like being a detective in our world. You're not just sitting around and waiting for security alerts to be triggered. Instead, you are out there, digging through the logs, actively looking for those sneaky threats that manage to slip past the first line of defense and are now hidden in the network. On this talk, you will learn this is a game changer in the defense strategy of organization. All right, let's get into the flow of proactive threat hunting. We start with a hunch on where threats might be hiding. This could be based on trends we've seen in the past, or even a gut feeling based on the understanding of the system. We can use then the attack framework to turn this hunch into a proper hypothesis, then start hunting for any signs of threats in our system. Sometimes our hunch doesn't lead anywhere, and that's okay. We just start over and look for new clues. But when we do find evidence supporting our hypothesis, it's the time to connect the dots by leveraging tools like Splunk and adding enrichments of information to the data. If you find a threat, you initiate an incident response process to address the issue, of course, and set up alerts to detect similar threats in the future. After we explained what proactive threat hunting means, let's dive into how we can use this strategy to hunt down cloud misconfigurations that could lead to threats, and worst case scenario, a security breach. Now, as a cloud security researcher, I've got my own lab of AWS and GCP accounts, which are likely my personal playgrounds for security testing. You can think of these accounts like my own little playground, where I can allow myself, without hurting any important infrastructure, to do mistakes that users could potentially make as well. So if you are planning to do some serious cloud hunting, the first thing you need to do is to make sure you are sending all your logs, all your AWS logs or GCP, especially your CloudTrail logs, to your security tool. It could be Splunk, Elastic, whatever you like to use. Personally, I'm a big fan of Splunk. So armed with Splunk and the curious mindset, I entered into this research. My initial research, to identify all cases from the last 30 days where a security group created or modified with a suspicious inbound IP range that tied to a risky ASN or from unusual geographic locations. All right, so after running my query in Splunk, I went through the results one by one. So in the left side is the CloudTrail log data, and in the right side is the data enrichment provided by Splunk. So on the left side, we have some security groups. Let's take the first two. And you can see in the description, Site 24/7, which is the monitoring for my system. Although it's in DigitalOcean, it was a bit suspicious. We have another security group named WAF, which has IPs that belong to Cloudflare Net. We see in the enrichment in the org, which is okay. And we have security group with private IP range with empty enrichment data because it's private addresses. And then something unusual caught my eye. Even though the security group description said private IP addresses, this seems to be matched with T-Mobile and AT&T. That's kind of weird, right? Okay, I won't lie. This threw me up for a loop. I was looking at these security groups and they described as private IP ranges, but when I ran the enrichment using Splunk, I found something different. These private ranges were actually connected to T-Mobile. What is going on? So I decided to take a deeper look and pull the full log, and then I even got more confused. Turns out I was the one who created that security group while setting up my cloud lab. I was still scratching my head at this point and decided I needed to double check. So I jumped over the IP info website, and yep, there they were. Those addresses were actually linked to AT&T and T-Mobile. I had to see it myself to believe it. Then it hit me like a lightning. I just discovered a new cloud misconfiguration. All right, now I was super excited. If I got mistaken, who else got wrong? I couldn't wait to dig into this more, to see if it's possible to grab one of those lookalike private IP addresses and figure out what kind of this mess unknown misconfiguration could cause. All right, but before we dive into that, let's hit the pause button and rewind a bit to cover some basic stuff. Back in '96, the guys in the IETF, the Internet Engineering Task Force, realized they had a problem. The internet was growing super fast, and they were running out of the 4 million unique IPv4 addresses. So they came up with the RFC standard. That standard allowed companies to use a bunch of IP addresses just for their internal networks. This IP addresses was also recognized by the INA, the Internet Assigned Numbers Authority, as private, meaning they're reserved for private use only and not accessible via the public internet. This created an added layer of security for internal network communications, like having a private phone line that can't receive calls from the outside. As a security guy, I have to say this move turns out to be a smart play for the network security. All right, let's take a look at the table here. This is a list of private IP addresses as per of the RFC standard. These are the addresses that you usually use inside your networks, and they're not meant to be accessible from the outside. Keep these ranges in mind as we move forward on the slides, or if you liked, I prepared some stickers. I put it in the table, so you can just take it. Sorry. So how this whole RFC standard, the one that's all about private IP addresses, plays out when we are dealing with cloud computing? Let's start by understanding what is VPC, Virtual Private Cloud. Think of a VPC at your own personal sandbox within the border of AWS Playground. It's a virtual network that's completely dedicated to your AWS environment. This means that stuff that you put in your VPC is just yours and doesn't get mixed up with anyone else's toys. One of the big things about VPCs is their logical isolation. They're like islands floating in the AWS cloud, separated from other networks. But a VPC is not just an empty space. It's also a platform for hosting AWS resources. They like a blank canvas that you can customize to fit to your needs. Setting specific IP addresses ranges, creating subnets, configure route tables, define network gateways, and deploying a whole range of AWS services, like EC2 instances. So when you are getting a VPC up and running, you have to give it an IPv4 CIDR block. This is pretty much a bunch of IP addresses that your VPC will use. As you can see in the screenshot that I have included, AWS is pretty clear about what to use. It suggests picking a CIDR block from the private IPv4 addresses ranges as specified in the RFC standard to avoid any confusions. Check out this diagram. It shows you how everything fits together in the VPC. Let's take a moment to talk about the difference between a public subnet and a private subnet. A public subnet is like an open house. It's got a route set to quad 0, which pretty much means it's ready to talk with the internet. Any instance you put in this subnet get a public IP address and ready to talk with the internet. And can be accessed directly from the internet. But a private subnet, that's a different story. Instances in the private subnet don't get a public IP address, and they don't have a straight path to the internet. But don't worry, you can still get to these instances. You know the other machines in the public subnet? You can use those as kind of stepping stone to connect to the instances in your private subnet. Now, going forward, it's been a pretty difficult task for me to identify the specific lookalike issues that could make our infrastructure vulnerable to threats. It was not entirely clear where and under which conditions this misconfiguration is applicable. Does the misconfiguration exist when we create a VPC using an IPv4 CIDR block range that looks like a private range? Will AWS even allow me to use a range that I don't actually own? I'm zooming a bit so we will see the lookalike range, which is basically AT&T cellular ranges. So, as you can see, AWS created the VPC without any warnings, even though the range not belong to me. However, using such an IPv4 CIDR block for a VPC could lead to IP address conflicts and routing issues. It's a blueprint for trouble. So I searched over AWS documentation and found that AWS lets you use either public or private IP ranges for VPC, but usually it's better to use private ones. Regardless of the IP range that you use, AWS does not allow your VPC to connect directly to the internet. For this, of course, you'll need to set up an internet gateway. If you end up using a public IP range that is not yours by mistake, as I did, AWS will still keep this information hidden. It won't be shown to the internet. But to avoid any possible network confusion, it's best always to use a private IP address to the range of your VPC. Anyway, seems that having a lookalike IP range in the VPC is not the misconfiguration that I have looked for. Let's shift our focus to AWS EC2 security groups. Basically, they are like traffic controls for your EC2 instances, deciding what comes in and what comes out, and what goes out. The cloud users set up some rules, and the security groups just follow them. Okay, so here the things can get a bit tricky. If you are setting up an inbound rule for your EC2 instance, and you accidentally use a lookalike IP address, what happens then? Well, instead of being exposed only to private ranges, your EC2 instance now exposed to AT&T and T-Mobile cellular ranges as well. That range looks like a private IP address, but it's almost 70 million IP addresses, contains also the private IP addresses, but also AT&T and T-Mobile, which will make it very hard to the cloud user to identify this mistake, because everything will work for him. He will enter from the private IP range and things will still be open. Let's move on to take a look on the example of how this misconfiguration can occur. So in this setup, we've got everything looks like under control. We got our VPC with its IP ranges set up correctly with the private ranges. We've got our sensitive assets setting nicely in the private subnet and some web servers in a public subnet that's supposed to be accessible only from our users from the VPN range. But wait a minute. As you can see, something not right here. It's turned out the cloud user configured the security groups incorrectly. Instead of just private IP ranges, they also include the AT&T and T-Mobile. That might seem to be a small mistake, but it could be a big impact on the infrastructure. With this misconfiguration, a malicious actor can potentially use a proxy server to gain access to your sensitive environment. Just like that, our supposedly secure setup has a gap in hole. Let's try to get access to that sensitive environment via the misconfigured security group. We'll kick things off by attempting to get a lookalike private IP range, spending just a few bucks and a minute of our time. So I searched over Google for a T-Mobile proxy, and now one of the websites that looked benign for me was that Leadport website. I was browsing through the different proxy packages and that the website offers, but I decided eventually to go for the second one. I mean, the hot label caught my eye. So, just kidding. This package gave me a shared mobile device with an IP address that changed automatically and allow access to all services. This is quite different from the cheapest package, which only lets you to whitelist only one website. So I went ahead and I found that I even can pick the career I wanted. For my case, this meant that I could select the specific lookalike IP range I needed. This was unexpected, but useful feature that made my research even more interesting. And check this out. You can even pay by credit card or crypto, if you would like to be hidden. 60 seconds later, after I paid my $5, I got an email that my proxy is ready. So I quickly entered back to the Leadport website and just got it. I started reviewing the proxy details, like the username and the password, and that's the IP address change every 10 minutes, but suddenly saw a tiny little field labeled as current IPv4. Think you can't see it, so I had to zoom really see it also in the real life. Hopefully you can see it, and there I had it. A proxy server which has the class B lookalike private IP addresses. Remember the infrastructure diagram? Now the attacker can make a hole in our sensitive infrastructure, yes, just using his proxy and bypassing our protection mechanisms. So now what? Let's see what we've got so far. We've identified the exact misconfiguration use cases, and we have our lookalike proxy server, proxy IP address to evaluate that. But we are still missing a few pieces in the puzzle. We need an attacker and a victim to really bring this scenario to life and understand the internet scope of this misconfiguration. Let's start with the attacker perspective, for the ones of you that are red teamers. So for our POC purpose, we prepared a new Kali Linux machine along with the lookalike proxy implement inside it that we just purchased, and CORL, the known command line utility. And for our victim, I prepared an EC2 instance in a public subnet installed with Nginx web server The EC2 itself was attached to a security group with the Lookalike private IP range. Just a kind reminder, that range contains almost 70 million IP addresses, along with the private IP ranges, but AT&T and T-Mobile as well. Let's see that scenario in action in my POC. Hopefully it will work. Cool. So we're doing CRL into the victim misconfiguration directly with the internet first, without a proxy. We got a timeout, of course, because of the security group, which not allowed you to enter. Let's check our public IP address. Maybe that's our mistake. Yeah, so we have a generic IPv4 address. That's why we got a timeout and couldn't have access to the resource. Now let's try to get our external IPv4 using proxy to see if we have a lookalike IP address. We have a lookalike private IP address when we query via the proxy. Now let's try to CRL the Nginx using our proxy server. Don't worry, those credentials are not valid anymore. Okay, so we got successful unauthorized access to the resource using our proxy. Now that I was able to bring this misconfiguration to life, I had to research after its scope over the internet to understand how many more people got mistake. So GitHub is a good place to start. There were today and yesterday a lot of talks that use GitHub to evaluate the scope of security issue. So it's also GitHub not require too much efforts rather than searching for code repositories that might contain some of the lookalike ranges. So for my searching over GitHub, I was able to find thousands of code files where most of them were very disturbing, such as Apache that told you to whitelist this address over superset, and dgraph, which is a graph database. I mean, what can go wrong? I also searched under HashiCorp GitHub for a repository that might contain Terraform codes with a lookalike private IP ranges. Of course, I found it as well. Happy to say that this morning, HashiCorp sent me an email, thank me on that, and they fixed it. So that's why I'm showing this slide. So even AWS had that error on their AWS CloudFormation documentation with an example of listener role for Elastic Load Balancer, exposing it for almost 70 million addresses, including private ranges, but also mobile ranges. How many users copied this and implement over their infrastructure? So after searching GitHub, I went to scan after possibly misconfigured cloud sources, such as EC2 that has that lookalike issue in their security group. To achieve this, I developed a multi-threaded scanner. This handy tool is equipped with a proxy configuration and capable of scanning an IP range on specific port, both with and without the use of proxy, to find such ones that were accessible only from proxy server. Despite being designed as a multi-threaded script, the scanning process can still take a bit due to a network exchange of the proxy server, and given that we were relying on mobile phone network. To confirm that my tool working correctly, I ran it on a small IP range that included my test victim machine, the Nginx one, to see if the scanner could successfully detect it as accessible only from the proxy range. And as you can see, it's worked. So once I had confirmed that my tool worked as expected, I needed a larger dataset to put it into a real test. The ideal place for this was the IP ranges that AWS shares with everyone. These ranges are grouped by regions and services. I couldn't ask for a better setup for that. So I took the EC2s in the US East 1 region to test it out. So I executed the IP Unmasker tool on the US East 1 EC2 IP ranges, and 3 hours later, I already got dozens of results that for instances that got accessible only from the proxy. Now comes, of course, the fun part. After you got some results, you need to start reviewing them. Of course, I found dev environments that got accidentally exposed to the mobile cellular ranges, sensitive internal company web services, Apache directory index of, listing of internal files, and more things. Here is some nice finding. You can't see anything, but the people at home probably can see in live. It was like internal web server with some link to get more Google Docs of development environment with, unfortunately, inside it, Google Docs links that those Google Docs links were publicly available to anyone with the link. So we got some more findings here. Yeah, it was that one. So when we discovered some misconfigured asset only on port 80, where my IP unmasker tool discovered, I thought there is a good chance that there might be more services, ports that are accessible only via the proxy. So to dig deeper into this, we'll be using a tool combo of ProxyChains and NMAP. ProxyChains, for the ones of you not familiar with that, is a Unix tool that built in Kali Linux and has ton of guides in Google by bug bounty hunters. You can use it to force any TCP connections made by any application in the OS, even once without any built-in proxy support, to go through proxies like Tor, HTTP, and SOCKS 5. It even allows you to use multiple proxies at once by chaining the proxies together. So as you can see in the following screenshot, I executed ProxyChains together with NMAP on the top 10 ports on one of the IP addresses that my IP unmasker discovered earlier, and this has allowed me to uncover additional services that were exposed only for the Lookalike private IP ranges. So of course, we need also to know how to detect the creation or modification of security groups, like as a defender in your cloud environment. So here you can see it's also being shared, of course, in my GitHub. I will share a QR code in the end of my talk. It's a Splunk query that it's really like using built-in functions of CIDR match to hunt after the creation or modification of security groups that include the Lookalike private IP addresses. You find this hunting rule for AWS and also for GCP, and I also built one in Sigma rules for any one of you using Elastic or any other SIEM platform under the GitHub repository of the talk. So that one was like, you can use Splunk for detecting from now on, but what about even preventing for the ones of you who want to prevent? So to prevent, you can use AWS config role, GCP organization policy, raise awareness for cloud users, keep your team informed about the risk of Lookalike IP misconfigurations, share that talk with your DevOps teams. You can take my stickers, of course, and also it's not shame to use a subnet calculator website to avoid mistakes. So let's talk about the shared responsibility model. The shared responsibility model in cloud services is a framework that determines who is responsible for what it comes to data and system security in the cloud. It splits the responsibility between the cloud service provider, the vendor, and the customer, which is the user. Let's check the responsibilities for this misconfiguration. So for the customer responsibility, in a security breach due to misconfiguration, it typically falls under the customer ones. As misconfiguration can happen when a customer doesn't properly set up their resources or lack of security awareness, resulting in potential security issues. However, cloud service providers also have a role in helping customers avoid these issues. They can provide tools, best practices, guidelines, and other resources to assist customers in properly securing their cloud environments. In fact, they can easily help avoid this type of misconfiguration by including an alert in the user interface or even a detection in guard duty when user is creating a security group with a Lookalike IP range. For example, when launching a new instance, AWS providing a message in the network settings tab, alerting from public exposure. But I'm not sure why that alert is missing when you're creating a security group with public exposure. Moreover, it's suggesting you to choose the public exposure. You know, after the Capital One breach in 2019, which happened due to user misconfiguration of security groups, AWS announced they will proactively scan their customer public IP address to identify potential misconfigurations. Interesting. I never heard on that. But if it happens, AWS, please add this lookalike misconfiguration for your toolset while you are scanning the IP address of all of us. So my recommendation for the cloud service providers is just adding a check button for public exposure or lookalike private IP ranges over security groups, as being done for S3 buckets. Hopefully it will decrease the common misconfiguration. Some closing words. So being a defender in the cloud world is not just keeping up with the bad guys. It's about being one step ahead of everyone, even our own users. Now, let's get real about the impact of what we are dealing with. If we only run a basic scan of a small chunk of AWS EC2 ranges in only one region and only look at HTTP service, imagine what a malicious actor with bad intentions could do. They wouldn't limit themselves to AWS. They can be all over GCP, Azure, and be scanning more AWS ranges than I did. And they wouldn't stop there, just scanning for open services. No, they will brute forcing their way through directories too on every misconfigured asset. And hey, here's a thought. We've been talking about lookalike IP ranges, but what about other things like S3 buckets? It could be the same problem there too. Maybe S3 buckets behind CloudFront might be something worth digging into. So I prepared the GitHub repository for the talk where it's your one-stop shop for everything we'll be talking today, packed with all of the scripts, the IP unmasker, and the security group unmasker that you need to tackle the lookalike IP misconfiguration issue in your environment. So go ahead, scan the QR code for the GitHub repository where these tools will give you the power to secure your environment. Happy hunting, guys. Hope you enjoyed the talk.
Any questions from the room?
Hey, did you report your findings to AWS?
Yeah, I have friends in AWS that I reported them, and also via the feedback in the documentation, but not about the lookalike thing. Only about the documentation that I found that had the issue, also HashiCorp, but not directly to AWS about that possible. Hopefully this talk maybe make some wave and they will hear about it.
Thanks.
Were there any other public findings that you reported other than HashiCorp?
Yeah, but I still can't talk about it.
Okay.
I mean, bug bounty hunters can use those tools for various ways to find more exposed assets of companies that were accidentally exposed to T-Mobile and AT&T.
So this might be a bit tangential, but didn't AT&T do something about you mass scanning? Didn't they throw in a wrench?
No, actually, I just use like the Leadport website, and they eventually I even purchased from them for $20 for 1 week a private mobile device, and I got even more speed, and I was able to scan more services in much speed way, but I didn't get any report, not from the proxy website, not from anyone, and even not from AWS. Even AWS not blocked my queries.
Okay, well, I feel like AT&T might have some new customers after today. Thank you.
Thanks.
I know you mentioned you only did a subset of the IP for scanning. How long did that take you?
Yeah, for that one, it was like 3 hours, I think. Yeah, 3 hours, and I got dozens. Yeah, that one, not, sorry. Yeah, I mean, that one. As you can see, I only on 1%. Yeah, 1% took me 3 hours because I scanned with some timeout to get some response because it's via the proxy. And I got dozens of results, and that's where I stopped. I didn't want to keep ahead with that.
Any other questions? Cool. Thanks again.
Thank you so much.
That's a great repository to check out. bit scared, but yeah. Okay, so we'll be back at 12:30 with Swimming with the Sharks IR Cubed from Nathan and Alon. Just a quick note, the food truck is serving burgers. So if you're hungry, go ahead and get your food. All right. Thanks again.